Okay, we have here on the board another interesting integral today. We have the integral of 1 over square root of 9x squared plus 1 dx. And I just want to credit adandap on this one, not for the problem, but for the method on how I'm going to solve it. What he mentioned in the comments in another video is a different kind of trig substitution that I'm going to use in this problem. Okay, so to get started with this, I'm just going to take my 9x squared and we'll rewrite this. I'm going to just noticing that 9x squared is a perfect square, and I can write this as 3x squared here in the radical. And then typically how I would do this one is I would take the 3x here and do a trig substitution where I set 3x equal to tan of t. And then from here we take the derivative, do all the normal things, and it works out fine. But the method suggested in the other video was instead of making our substitution of 3x for tan of t, what he did was make the substitution for sinh of t, or hyperbolic sine. And this is going to work out pretty nice. If I take my derivative, we're going to have 3 dx equals cos of t dt. So I think what I'll do first is just divide by 3 here, so we've isolated our dx, so that's going to cancel off. So for our dx, I'm going to bring the 1/3 out front. That's going to give me cos of t in the numerator. And then here 3x is sinh, so I can write this as sinh squared t plus 1. So we have this identity over here to the right that cos squared minus sinh squared equals 1. Well, if I just add a sinh squared on both sides, I get cos squared of x equals sinh squared plus 1. Well, that's really what we have here. So I can take this and I can actually write this as cos squared of t. But this here is inside the square root, right? So when I rewrite this, we'll have our cos t in the numerator. And then square root of cos squared, this is going to give me actually absolute value of cos t here. So let's just look at the definition of cos t. So this is actually going to be equal to e to the t plus e to the minus t all over 2. But notice, of course, e is positive. It's like 2.718. So what's going to happen is this numerator is always positive. The 2 is always positive. So this is always greater than 0. And that's going to allow me to just drop my absolute values here. And that's really nice because then we just cancel that off and we're just integrating 1. So then when I integrate this, we have our 1/3 out front. Integral of 1 is going to be just t. Now we can get a value for t just by taking the inverse here on both sides. So isolating our t, we have t is the inverse sinh of 3x. We'll just back substitute that right here, and we get a really nice solution, 1/3 sinh inverse 3x. You may be wondering, why does this solution look different than the solution I get if I do the trig substitution using tangent? Well, we have this definition here for the inverse sinh function, and we can put it in terms of natural log. So I can just rewrite this solution using this formula. So we can write it as 1/3, and then we're going to have natural log. Our t value is going to be 3x, plus square root of 3x squared is going to be 9x squared plus 1. And this here should be what you get if you make the trig substitution the traditional way. Okay, good problem and really interesting method today. So I'll stop it there. Thanks everyone for watching. Have a great day.